All right, what about powers of I? Sometimes we can have powers that are huge for I. It doesn't have to be just 0, 1, 2, 3, or whatever. And so what we can do is if they have a value of I to the n, we can divide n by 4. And if the remainder is r, then whatever whatever that remainder is, that's going to be what n is now, okay? So if we divide it and we get r is 0, that means I to the 0, which is 1. If r is 1, that means we get I. If I is 2, then that means I squared, which is negative 1. And if, say, I is 3, then n is 3, so we get a negative I. Okay? And so that is going to be the key pieces. If you can remember those four, and all you have to do is divide whatever your n is by 4, and the remainder is going to either be 0, 1, 2, or 3. And then it just can be either 1, I, minus 1, or negative I. So 25. Well, if we divide 25 by 4, we get a remainder of 1, and a remainder of 1 just says I is to the 1 power, so that gives us I. What about dividing that by 4? Well, that gives us a remainder of 3, and if we remember, I cubed is equal to a negative I. And another way to think about that is how did they get that? Well, if we know I is going to be, I to the first, and that's that one. And then if we take I squared is equal to what was that? Well, that was going to be, now don't forget, it's all here, so you don't have to worry about it. It's just negative 1, because if we have the square root of negative 1 equals I, negative 1 equals I squared, so that's negative 1. So this times this is going to give us whatever I cubed is, because a 1 plus 2 is 3, so we have an I times a negative 1, hence the negative I. And our final one, dividing by 4, that's going to be 11, no remainder. So it's I to the 0, and anything to the 0 power is 1. And so that would be our solution here. All right, now we want to write each quotient in standard form, which means we don't want a denominator with an I in it. So we're going to have to multiply by the conjugate. Okay, so the conjugate of that is going to be minus I, which is like that. Now we multiply everything out and it gets long and drawn out here. So we're going to have 15 minus 3i plus 10i and then minus 2i squared. And then here we're going to have 25 plus 5i minus 5i and then minus I squared. And so simplifying that, we're going to have what is it? 10 minus that's going to be a 7. That's going to be I squared, so that's going to be a minus 1. So that's going to be plus 2 and 15. So that's going to give us 17 once we get down here. And then that was 7i here. And then if we do that, it's 25. And then so that's going to be minus 1. So it's going to be minus a minus 1, I should say, is 26. And so that's going to be in a single form. And if you split it into the two pieces, which is kind of the standard form, the a plus bi, where's my marking thing? This is kind of a plus bi, then that's going to be the form we have here. Okay. What about this one? Well, here we have 3i, so if we multiply by negative 3i, we should get rid of the answer. And so now that's going to be what? A negative 27i over a negative 9i squared, but I squared is negative 1, so it's going to be over 9. And now we can divide that, and that's going to be a negative 3i. Okay, and so that's going to be your solution to this one. So again, a lot of playing with numbers, but again, knowing the conjugates of these is going to be the key to being able to solve it. And then it's just distributing and then keeping track of, i's, I squareds, and just real numbers. Okay. All right. So that finishes that section. Hopefully that will help you at least get problems started.